So let me recopy this example here. So we've got 6x plus 5 over x squared minus 3 plus 3x minus 1 over x squared minus 3. Now, do you guys see that we already have a common denominator? So if we already have a common denominator, we can just go ahead and add the numerators. So we have a common denominator of the quantity x squared minus 3, so we're going to keep that on the bottom. And then we are just going to add the numerators. So I'll write it out on this one. So all we have to do is do 6x plus 5 plus 3x minus 1. So what do we got up there on the numerator? Can anybody tell me? How many x's do we have? How many? Yep. Yeah, we have 2x terms there, but we got a 6x's plus 3x's, bless you. So we got 9x's. And then we got a plus 5 minus 1. So plus 4. And then that's over our common denominator of x squared minus 3. And that's it. So that's not too bad, right? These don't get messy until you got to make a common denominator. All right, so let's look at 1b here. So let me go over to the other side. So 1b. Well, this one's not going to be that bad either because we already have a common denominator. Do you guys see that? So that shouldn't be too bad. So this one, again, I'm just going to keep my common denominator. It's 3x minus 1. And then I just have to add the numerator. Well, when I add the numerators here, do you see that it's actually a subtraction? So you got to be careful on this because that subtraction right there, that applies to that entire numerator, this thing right here. So if you want to think of it, again, I wouldn't normally show this, but I'll write it out for you guys. So our common denominator here is 3x minus 1. So we'll keep that. We always keep our common denominator. And then we'd have 3x squared minus 5. Can't make a squared. 3x squared minus 5. And then the important thing is that minus in the middle, that subtraction right there. That subtraction applies to that entire numerator on the right there. So inside the parentheses here, I'm going to put 2x squared minus 3x minus 2. So what am I going to have to do with that minus or that subtraction? Yeah. Yeah, I have to distribute it. Good. It's actually kind of like it's a -1 that I'm going to distribute into those parentheses on the right. So that negative right there, that has to get distributed onto this term and onto that term and onto that term. All right, so if I do that, then my numerator is going to become 3x squared minus 5. And then if I distribute that negative, it's going to become a negative 2x squared plus 3x plus 2. Hold on, my chair keeps messing up here. There. You guys good with that? So basically, when I distribute that -1, it's just changing the sign of every term inside the parentheses on the right. And then that's still all over my common denominator of 3x minus 1. And then all I got to do is combine like terms in the numerator. So you can see these two terms are alike, this one and this one. So how many x squareds do I have?
1.
Just 1, yeah. 3x squareds, take away 2x squareds, leaves me with 1x squared. So I just get 1x squared, or x squared. And then I have a plus 3x, I'll bring that down. And then I can combine the, I got a -5, and I have a positive 2. So what's -5 plus 2? Negative 3? Okay, thanks. So that's a negative 3. And now that's all over my common denominator of 3x minus 1. Now that is my answer. But technically, I'm supposed to look at this one now, right here, this one. And I'm supposed to look at that and see if that would factor. But I don't think it does. Because you would need two numbers that multiply to negative 3 that would add up to positive 3, right? I don't think that could happen. The only thing that multiplies to negative 3 would be negative 3 and positive 1, which would add to negative 2. Or it could be positive 3 with a negative 1, which would add up to positive 2. So that one does not factor. That trinomial on the top up there, that is prime. So then this is your answer. I'll show you one. I think I have one example for later on in the lesson where this trinomial you get in the numerator, it actually factors and then it ends up canceling out with the denominator.
Wouldn't you be able to cancel out both of the x's?
No, because there's addition and subtraction in between, remember? It's only if that was all multiplication, like if it was x squared times 3x times 3, and then a 3x times 1 or something like that, yeah, then you could. All right, we got 2 examples done, we got 3 to go. But unfortunately, they're a lot more messy than this one. So let's, you guys good on that? Let's turn the page. So if we turn the page here, let's see, which one did I want to do? We're going to skip to number, I like this example 3 here, part A. So let me rewrite this problem over here. If I can slide over here. I should probably have my mouse because I can scroll that screen a little bit over there and get more room. So let me grab that. All right. So again, I'm looking at this example 3A. So if I can get this thing over here where I can work on it. Let me slide down a little bit. There we go. So I think that'll probably work. Okay, so here we go. So we got this example 3A. So I'm going to recopy the problem here so you guys can see it over here. So what we've got is we've got x minus 1 over x squared plus 3x plus 2. And then that's plus x over x plus 1. Well, we can only add the fractions if we make the denominators the same. We have to have a common denominator. And we cannot see what that common denominator would be until we factor the denominators. So we have to factor them. Well, the one on the right, we don't have to do anything with that one, but we got to factor this one on the left. So let me rewrite this thing for you. So we're going to do x minus 1 over. And again, this is why the factoring is super important in this chapter. So on this one, a times c would be 2. So we need two numbers that multiply to 2, where the same two numbers would add to 3. So what would that be? If you want me, I guess I could do this one more time for you guys. Usually if they don't have a, like if the a on this is a 1, I usually kind of just do it real quick. But I'll do it one more time here for you guys. So we need two numbers that multiply to a times c, which would be a positive 2. And we need the same two numbers to add up to b, in this case is a positive 3. So what would that be? Yeah.
2 and 1.
Yeah, just positive 2, positive 1, right? So it's going to be a 2 and a 1. All right. So it's a positive 2. So you're going to write plus 2. And it's a positive 1, so you're going to write plus 1. And then we're going to rewrite the second fraction here. So this one is x over x plus 1. Now we want to make these denominators the same, right? So what is this denominator missing? If we wanted to make it look like this one. Yeah.
X plus 2.
Yeah, it's missing the quantity x plus 2, right? If we want to, both denominators already have the quantity x plus 1. So this one on the right here is just missing that quantity x plus 2. So that means all we got to do then is we're going to multiply this fraction on the right by x plus 2 over x plus 2. Now we have a common denominator. So I'm not changing that fraction, okay? X plus 2 divided by itself is really 1, right? I'm just changing the way the fraction on the right, I'm changing the way that it looks so that I have a common denominator, that's all. All right, so then we already know now our common denominator is going to be the quantity x plus 2. So it's going to be x plus 2 times the quantity x plus 1. So that's our common denominator, so we're going to keep that. All right, and then we just got to add the numerators. Now, when we go to add the numerators, how I want you to see this now is this is really a positive x right here, okay? And it's going to distribute onto this quantity, like that. So that means my numerator on the left here, that's still just going to be x minus 1. But then I'm going to take my positive x times x. Well, that's going to give me a positive x squared, right? So that's going to be plus x squared. And then I'm going to distribute my positive x times my positive 2 right here. Well, it's going to give me a positive 2x. So since it's a positive 2x, I'm going to write plus 2x. And then all I got to do to finish this thing is I just got to add the numerator together, that's all. So combine any like terms. So in the numerator, I have x squared. And then I have, I got a 2x right here. And then I've got a 1x right there. So I got to add those together. So it's going to give me a 3x. So plus 3x. And then I got to bring down that minus 1 right here, that one. So bring that down. And then that's all over my common denominator of x plus 2 times the quantity x plus 1. Now you'll see sometimes in the book, they will multiply this all out down here. It's not worth it. Just leave it in factored form. All right? Now I told you need to also look at your final answer up here in the the numerator of your final answer. And you got to say, does that thing factor? Because that could factor again. That could possibly factor, and then it might cancel with one of these factors on the bottom down here. But I think you can see that one doesn't factor either, right? You would need two numbers that multiply to -1, where the same two numbers would add up to 3. And the only numbers that multiply to -1 would be 1 times -1, right? And that's not going to add to positive 3. So that is your answer. And then this one does say to identify any, let's try to start doing that a little bit. So this one says identify any x values for which the expression is not defined or undefined. So let's do that real quick on this one. So what could you not put in right here? What would cause division by 0? Yeah, you can't put a -2 in right there. Do you see that? Because -2 plus 2, that would be 0. And then 0 times anything would be 0. And then you'd be dividing by 0. You can't do that. And then what can you not put in this one? Yep, you can't put -1 in that one because -1 plus 1 would be 0. And you can't divide by 0. So then you want to make a little note here. We're going to say x cannot equal -2. And x cannot equal -1. And then we'll circle that. That's our answer. So that's 3 of them, right? Let's see. I think there's 3 more. I thought there was 5, but I think there's 3 more. So let's look. I think that might be it for that page. Yep. So let's turn the page. And let's look at, what do we got here? Anything interesting? Yeah, this one's kind of interesting. Let's do this one. So we're going to look at this 3A example right there. So right there. I can slide over. There we go. So this one, I'll recopy it for you guys. This one says 3x over the quantity 2x minus 2 plus 3x minus 2 over the quantity 3x minus 3. So again, we cannot make a common denominator here until we factor first. All right, we want to make the denominators the same. So both of these denominators are common factor, greatest common factor problems, I guess. All right, so what's the largest number that goes into 2 and 2? 2, yeah. Same thing on the other one, right? So what we're going to do is we're going to go, this is going to be a 3x over, we're going to factor out the 2. And then we're going to fill this in, again, remembering we're kind of doing the distributive property backwards. So this would have to be a what? X minus 1. Again, if you check that, you'd have 2 times x. Well, that would give you the 2x. Then if you distribute the 2 times the negative 1, that would give you the negative 2. All right, same thing on the other fraction. So this one, the numerator is still 3x minus 2. The denominator, we can factor out a 3. The greatest common factor is a 3, and then that's going to give us a x minus 1, right? All right, so now we got to think about how would we make these denominators the same? Okay? So both denominators already have the quantity x minus 1, right? They both have that. But this one has a 3 and that one has a 2. So kind of think back to your basic math. Like think back when you were doing like, you know, if you had like, I'm going to erase this, don't write this down. But if you had like 1/2 plus 2/3 or something like that, what would be your common denominator? Yeah, it'd be 6, right? It's the smallest number that, what is that called? The least common multiple. It's the smallest number that 2 and 3 to both divide into evenly, right? Uh-oh. Give me a second. I have this is, sorry about that. There you go. All right, so what you're looking for is you're looking for the smallest number, again, the least common multiple, the smallest number that 2 and 3 both divide into evenly, which would be 6. So then, when you were doing basic math way back when, what you guys would do then is you would go, okay, well, I'll multiply this fraction by 3 over 3, right? And then I'll multiply this fraction by 2 over 2. And now I'm going to have my common denominator. Remember doing that? So now what would you have? You would have 3 over 6 plus 4 over 6. You'd add your numerators and you'd get 7 over 6, which is 1 and 1/6, right? So we're going to do that same thing, but with the messy algebraic fraction stuff. So then, let me erase this out of here, because we don't need all that. So then you guys tell me, what would I multiply the fraction on the left by? Yeah, I need to make the common denominator for 2 and 3, which we said was 6, right? So I'm going to multiply this fraction over here by 3 over 3, and then I'm going to multiply this one by 2 over 2. Same kind of idea, right? Now, if I do that, let's see. You can see right here, I guess I could draw this on here. Right here, you're going to have a 3 times 2, right? Right there. And that's going to give you a 6. Over here, you could also do the, I don't know how would I denote this thing for you guys. You're going to do this 2, or you can multiply in any order you want, right? So multiplication is commutative, so we're going to do that 2 right there times that 3 right there. And that's going to give me a 6 also. So now let's see what we got. So if I go to write this thing out, now my common denominator is going to be 6 times the quantity x minus 1. All right, both of those fractions have that same denominator, 6 times the quantity x minus 1. And then in the numerators, well, I've got to do this, I've got to do 3 times 3x, right? So that's going to give me 9x. So that gives me a 9x. And then over here on the right, I got to distribute, even though I kind of wrote it backwards. So I kind of wrote this thing backwards, but I do have to distribute this thing. So I'm going to do the 2 times the negative 2, and I'm going to do the 2 times the 3x. So 2 times the 3x, that's going to be, what, 6x? So hold on here. So that gives me 6x, and then the 2 times the negative 2 is a negative 4. All right, so then I just combine like terms in the numerator there. So I've got 9x's plus 6x's. That gives me 15x's, right? So that's going to give me 15x minus 4 over 6 times the quantity x minus 1. And that's going to be my answer. Now, you're supposed to look at that numerator real quick and say, wait a minute, can I factor that at all? The greatest common factor, or there is no greatest common factor greater than 1 for 15 and 4, right? So that is our answer. So I'm just going to circle that, and we're going to call that one good. All right, let's keep going here. I think we got 2 more to go. So let's see, are we on the same page here still? Yeah. I think I like this one. Yep. So we're going to do this example 4. So let me slide over here, if I can. What is my issue here? Hold on a second. There we go. So let me recopy this thing. So this one is 2x squared minus 16. And that's over x squared minus 4. And then that's minus x plus 4 over the quantity x plus 2. So again, we want to factor, like when we were doing the multiplication and division problems from yesterday and from Tuesday, we wanted to factor everything. These problems, we really only want to factor the denominators because we want to make a common denominator. Now, this one I didn't talk about a lot in class, but does anybody know what this one factors into? This is the difference of 2 squares. We did this on Delta Math. What that really is, here, I'll put a little hint up here. Don't write this down. I'll erase it in a minute. So what that really is that's x squared minus 2 squared, right? So you're looking for those perfect square numbers like 1, 4, 9, 16, 25, 36, 49, 64, 81, those numbers. So does anybody know what that factors into then? Yeah.
X minus 2 and x plus 2.
Perfect, yeah. So when you see this situation where it's something squared, it has to be a minus in the middle, okay? It's got to be the difference or a minus. So it's x squared minus 2 squared, so that's going to factor into x plus 2 times the quantity x minus 2. All right. So let me just go ahead and do that up above now. I'm going to erase it there because we don't need it right there. Okay, so here we go. So we're going to leave that numerator alone. Now, you notice that numerator would factor, right? You could factor a 2 out of that numerator. A greatest common factor in the numerator would be 2. But don't do that. We're on these, when it's addition and subtraction, we're only factoring the denominators to make a common denominator. So that denominator on the left, again, that's going to factor into the quantity x plus 2 times the quantity x minus 2. And maybe I should have left myself some more room here. I don't know. Yeah, let me move this over a little bit. Hold on, guys. I want to come over here. So that's going to give me 2x squared minus 16 over the quantity x plus 2 times the quantity x minus 2. And then, let's see, how do I want to do this? I think we'll be okay. And then we got x plus 4 on the numerator, and we got an x plus 2 in the denominator. So what is this, what's this fraction on the right? What's it missing there to make the denominator the same? Yeah,
X minus 2.
yeah, it already has the x plus 2, like the one on the left. But it needs that x minus 2. So we're going to multiply the fraction on the right by x minus 2 over itself. Which you want to remind yourself, that's the same thing as 1, right? You're just changing the way that it looks so that you can combine it with it, or so that you can add or subtract with a common denominator. All right, so let's see if we can do this now. So let's do, let's see, what should we do? Well, we know our common denominator, so we'll write that. So we know our common denominator is the quantity x plus 2 times the quantity x minus 2. So that part's done. And then in the numerator, we have this 2x squared minus 16. But then, very important on this one, is we have this subtraction right here, right? So I want to note that I have a subtraction right there. And then we've got to multiply all this stuff out over here. All right, we got to multiply this out. So if you remember how to do that, we're going to have to do the x times both of these terms, right? And then we're also going to have to do this positive 4 times both of these terms, which you may have heard that called FOIL, right? So in the blue there, we would have what? We'd have x times x would give us x squared. And then we'd have x times negative 2 would give us negative 2x. And then in the green there, we would have positive 4 times x, so it's positive 4x. And then we'd have positive 4 times negative 2 would be a negative 8. So it would look like that. And then, now the important part here is that minus that I had in the middle, this thing right here, that thing, that applies to that entire numerator on the right. So what you want to do now is you want to put this thing in parentheses, because that minus right there, or that subtraction, let's see, let me get a different color here. That subtraction, that would distribute onto all of these things, right? Now, just to save a little space, I think I'm going to combine like terms right here, right now. Notice in the middle right here. In the middle right there, I've got a negative 2x plus 4x. Oh, that's not good. I have to reset the, I'm going to reset this already. I'm just going to reset this so it doesn't keep turning off my screen. It's weird because I taught a really long lesson the other day on that and that didn't happen. Maybe I guess if I move my mouse around once in a while or something, that would probably help. Oh, hold on, I left my pencil up there. What did I do with it? Oh, it's right there. Okay, sorry about that. But anyways, in the middle there, we had a negative 2x plus 4x, so that's going to give us a 2x. That's a positive 2x, right? And then we've got to distribute that negative. That's the important point that I'm trying to make. So that subtraction that's in the middle between those two fractions right there, that thing right there, that has to distribute onto this term and onto this term and onto that term. So that's the tricky part. So let me do that. So now our numerator is 2x squared minus 16. Then I'm going to distribute that negative. So the negative is going to go onto the x squared right here. So that's going to give me a negative x squared. And then again, it's like a negative 1. It's going to distribute onto that positive 2x right there. So that's going to give me a negative 2x. And then it's also going to distribute onto that negative 1 is going to distribute onto that negative 8. So that's going to become a positive 8. And then that's still all over my common denominator of x plus 2. Oh, hold on here. X plus 2 times the quantity x minus 2. Now we got to combine like terms up there in the numerator. All right, so what do we got? we can combine the 2x squared minus x squared. So that's going to give us 1x squared, right? And then we've got a minus 2x that we can bring down. And then we also have a negative 16 plus 8. So that's going to give us a negative 8. So since it's a negative 8, we're going to write minus 8. That's subtraction right there. That implies that that 8 is negative. And now that's over the quantity x plus 2 times the quantity x minus 2. But then I told you to also watch these things, because remember we keep checking these numerators here to see if they factor. I mean, technically that's the correct answer. If you look it up in the back of the book, they might have that there. But I believe that this one also factors. So that's going to break down further. So let's try it. Okay, so we got an x and an x. So on this one, we're going to need two numbers that multiply to a times c, which is going to be negative 8 right here, right? So we need two numbers that multiply to negative 8, where the same two numbers add to negative 2. Yeah, what do you got?
Negative 4 and positive 2.
Negative 4, positive 2. That sounds good. So let's try that. Negative 4 and positive 2. So if we do that, let's see, if we multiply those together, we get negative 8. If we add those together, we get negative 2. So we got it. Well, what cancels out now? Yep, the quantity x plus 2 in the numerator and denominator cancel out. So now you got these two quantities cancel out, that one and that one. So then your final answer on this one, if I can fit it in here, it's going to be x minus 4 over the quantity x minus 2. And on this one, I think let's make the note about any values that would make the expression undefined. So what can you not put in right here? Yeah, x cannot equal 2, right? But then even though this canceled out over here, you still got to look at that. So what can x not be right here? Yeah, it can't be negative 2 because that would cause division by 0. All right, so that means we're going to make a little note here then. So then we're going to say x is not equal to 2. X is not equal, I could have put plus or minus 2, I guess, but x can also not equal negative 2. So that's your final answer then. And I was going to do, there is one more example, but I think that's enough for right now. So let's, we're going to stop there, and then maybe I won't see you guys again until when? Yeah, maybe well, on the next video then, I'll try to do a little quick blurb on how to do that last problem, okay? So I think that's enough for one day, though. So let me stop this recording. Let's see.